You press a button, and a huge motor starts running. You press another one, and it stops. And even when you take your hand off, it keeps running. The thing that makes this happen is called a control circuit. And this logic sits behind almost every machine in industry. In this video, you'll learn what a control circuit is, what it does, and where it's used, starting from zero. And not with dry theory. We'll build everything live, on screen. This is the first episode of a new series that teaches automation from scratch. We'll start with classic control circuits and work our way up, step by step, to PLC programming. Never touched electricity before? No problem. You'll see everything in detail, built live on screen. If you want, you can download the simulator and build along with me. The link is in the description. Let's get started. Inside a machine, there are actually two separate circuits. The first is the power circuit, the thick cables that carry the heavy current and actually turn the motor. The second is the control circuit, the thin, low-voltage wiring that commands that power circuit. The control circuit has one job, controlling a big load with a small signal. You press a small 24-volt button, and it triggers the contactor that runs a 380-volt motor. And this is the heart of it, the contactor. Feed a small current into its coil, and the contacts inside snap shut like a magnet, letting the big power flow to the motor. Managing a lot of energy with just a little. That's the whole idea. So why don't we just switch the motor directly with a cable? For reasons. 1. Safety. The operator touches a safe 24-volt button, not 380 volts. The dangerous power stays inside the panel. 2. Automation. You can add sensors, timers, and counters, and the machine makes decisions on its own. 3. Remote control. Put the button wherever you like. The motor can be meters away. 4. Protection. Thermal relays, fuses, emergency stops. When something goes wrong, the circuit protects itself and the machine. Now let's build the most fundamental control circuit of all, the start-stop circuit with CLN. The ABC of industry. Press the start button and the contactor coil energizes, the motor runs. But release the button and the circuit breaks, the motor stops. That's not what we want. Here's the trick. We wire one of the contactor's auxiliary contacts in parallel with start. When the contactor pulls in, that contact closes and takes over from the button. The circuit seals itself in. Now the motor keeps running even after you let go. To stop it, we press the stop button wired in series. The seal-in chain breaks, and the motor stops. Start, stop, seal in. Understand these three, and you already understand half of control circuits. Where isn't this logic? Conveyor belts in factories, water pumps in buildings, cranes and elevators, ventilation and air conditioning, every machine on a production line, even parking barriers and automatic doors. Behind all of them, the same foundation, a small signal managing a big load, safely and automatically. If you want to become an electrician, a technician, or an automation engineer, this is where you start. In the old days, all of this logic was built with dozens of relays and contactors, wire by wire. But those relay panels had serious downsides. Hundreds of wires, huge cabinets, and worst of all, when something failed, finding the fault was a nightmare. You'd spend hours tracing which relay or which wire had gone bad. And even the smallest change meant rewiring the circuit. Today, a single box does the same job, the PLC, the programmable logic controller. You build the circuit in software instead of wires, so finding faults, making changes, and scaling up all get far easier. In this series, we'll first master classic control, then rebuild the same circuits on a PLC using ladder diagrams. Knowing both is what makes you a real automation engineer. So where is this series headed? We're starting from zero. First, we build a solid foundation in control circuits. Buttons, signal lamps, contactors and relays, sensors, start-stop and seal-in, protection and emergency stops. Once that base is in place, we move to the PLC side. Core concepts, digital inputs and outputs, ladder diagrams, timers, counters, and finally, a real project. So this isn't just one video, it's a complete roadmap, and we'll build every step of it together on screen. If you found this useful, subscribe. In the next episode, we'll get to know the basic components one by one. See you in the next one.